We're now going to learn how differentiability and continuity of a function are related and walk through some examples. There are three main facts about differentiability and continuity that we need to know. Here's the first one. If a function is not continuous at a point x is equal to a, then it is not differentiable at that point. I've put down here some examples of where a function is not continuous and hence not differentiable. Our first function is where we have a removable discontinuity at x is equal to a, and a function that has this type of removable discontinuity can look like this. F of x is g of x times x minus a over x minus a, where the x minus a's cancel out, and of course g of x is defined at x is equal to a. A function is also not continuous where it has a jump discontinuity, like at the point x is equal to a, and this function f of x is often a piecewise function where it's defined to be g of x when x is less than a and h of x when x is greater than or equal to a. The third type of an example where a function is not continuous is where it has what we call an infinite discontinuity. Here's an example of a function that has an infinite discontinuity and it has a vertical asymptote at x is equal to a. So in all three of these cases, removable, jump, and infinite, our function is not continuous at x is equal to a, and so it's not differentiable at x is equal to a. Here's our second fact. If a function is continuous at x is equal to a, it may or may not be differentiable at x is equal to a. So this basically tells us that continuity does not imply differentiability. Let's look at some examples of where a function is continuous but not differentiable. One of these cases is called a corner, and at this point, our function is not differentiable. This function is f of x is the absolute value of x minus a. The next type of function that is continuous but not differentiable is where we have what's called a vertical tangent. So at some point on a graph, the slope is infinite. An example of this type of function would be f of x is x minus a raised to the 1/3 power. The last type is where we have what we call a cusp. A function is not continuous and then not differentiable at the point where you have a cusp. An example of this is the function f of x is x minus a raised to the 2/3 power. The third fact is that if a function is differentiable at x is equal to a, then you can know that it is also continuous at x is equal to a. Whenever I teach this concept in class, I like to summarize these three facts in a chart. The first point is that if a function is not continuous because of a removable, jump, or infinite discontinuity, then it is not differentiable. The second part tells us if a function is continuous, it can be either differentiable or not differentiable. And if it's not differentiable, the function will have a corner, a vertical tangent, or a cusp. And then lastly, if a function is differentiable, it is continuous. Let's now look at an example where we are given the graph of a function f, and we want to state where the function f is not differentiable. Over here on the right, just as a reminder, I wrote down that a function will not be differentiable if it has a removable, jump, or infinite discontinuity, or if the function has a corner, a vertical tangent, or a cusp. Let's start looking at our x values as we go from left to right. When x is equal to -5, we have what looks like a cusp. So at x is -5, our function is not differentiable, and the reason is that we have a cusp. Let's now look at x is equal to -4. At that point, we have an infinite discontinuity, So our function is not continuous, and that means that our function is not differentiable. So let's write down x is equal to -4. We have an infinite discontinuity. Now let's look at the next point. That point is going to be -2, and at that point, we have a removable discontinuity. So our function is not continuous, and that means that our derivative is not continuous. So we'll write down x is equal to -2. We have a removable discontinuity. Now let's go over to where x is equal to 1. Here we have what's called a jump discontinuity. So our function is also not differentiable at x is equal to 1. And we'll write down jump discontinuity. And then we have one more point to look at, and that is where x is equal to 3. And notice on our graph that we have a vertical tangent at that point. So at x is equal to 3, our function is continuous, but the derivative is not differentiable. So we can say that we have a vertical tangent there. And that is why our function is not differentiable.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.